In this lecture, we will learn the necessary and sufficient condition for a linear transformation to be invertible. Secondly, we will learn composition of two linear transformation is again a linear transformation. Okay, and third, we will prove that when we have a linear transformation from V to V dash and T of x1, T of x2 and T of xn, this is the image element and this forms a linearly independent set. These are Li. Then we need to show x1, x2, xn are Li. Okay, so we will discuss these three things in this. So please subscribe my channel if you haven't subscribed yet. Okay, so now necessary and sufficient condition for a linear transformation to be invertible is that there exists as a linear transformation from W to V. We should have a linear transformation as such that it is W to V such that composition of S and T equal to identity. Okay, this is identity map and this should be equal to T of S. Okay, this is the necessary and sufficient condition for a linear transformation to be invertible. Here the operation between function S and T is the composition. Okay, and how it will be defined for all x s t of x equal to s t of x. Okay, now we will show that composition of linear transformation is again a linear transformation. So assume we have a linear transformation T which is from V to V dash and a linear transformation S which is from V dash to W and its composition is S of T which will be V to W. Okay, when we take an element it will be in Tx which is in V dash and then S of V dash image should be in W. So S of T will be Vf to Wf. And how it will be defined? It is defined by S of T of x equal to St of x for all x. Now we will show it is a linear transformation. How it we will show? Let x1 comma x2 belongs to V, a vector space. So need to show S of T of x1 plus x2 equal to S of T of x1 plus S of T of x2. We need to show this equality. So we can write here S of T of x1 plus x2 equal to S of T of x1 plus x2 by definition of composition. Okay, and also since T is a linear map, we can write here S of T of x1 plus T of x2. Okay, and since S is a linear map, we have S T of x1 plus S T of x2. Okay, this element is in V dash. Okay, because T is a linear map from V to V dash. So this element in V dash and S is a linear map which send element of V dash in W. So it is well defined and S of T of x1 can be written as S of T of x1 plus this can be written as S of T of x2. Okay, so we have proved this one. Also, what we need to prove, s of t of lambda x1 equal to lambda s of t of x1. We need to prove this one, so we can prove easily. Here we can write here s t of lambda x1, okay, by definition of composition of functions, and we have t as a linear transformation, so we can write here as lambda t of x1, okay. And since s is a linear transformation, we can have lambda s t of x1, and this will be equal to lambda s of t of x1, and x1 was arbitrary element. X1 belongs to, let x1 belongs to V. Hence we have proved that composition of two linear map is again a linear map. Okay, now we will prove that when image set is linearly independent of a linear transformation, then pre-image set will also be linearly independent. Okay, so what we need to show for linearly independent, it is easy to prove. Okay, so let c1 c2 dot cn belongs to field such that c1 x1 plus c2 x2 plus dot cn xn equal to 0, taking both side t. Okay, what we got here, t of c1 x1 plus c2 x2 plus dot cn xn equal to t of 0. And now in my previous lecture we have proved that t of 0 is 0 vector, and since t is a linear map, we have the property of linearity, that what we can write here, t of c1 x1 plus t of c2 x2 plus dot t cn xn. How we have written this statement? Because t is a linear map, we have given t is a linear transformation. Okay, now also we have c1, because of linearity we can write this x1 plus c2 t of x2 plus dot cn t of xn equal to 0. And now we have given that t of x1, t of x2, t of xn are linearly independent. What does mean by this? The ci equal to 0 means c1 equal to 0 equal to c2 dot cn equal to 0. Okay, this is true because we have tx1, tx2 dot txn are linearly independent. This statement was given. That's why we can write c1, c2, cn equal to 0. And this is what we need to prove for x1, x2 dot xn to be linearly independent. Okay, so thank you for watching this video.